pleasant morning to each and everyone. We are the Group 5. We will talk Chapter 7, Linear Programming. We have the objectives, able to understand about linear programming, able to apply mathematical concepts and tools including business, finance, networks, and system. Able to know that linear programming is the use of mathematics in any various aspects in problems. And also our title, the use of linear programming in any problems. And last is our theme, linear programming, the method of solving a problem. We will discuss 3 topics, which is 7.1 linear inequalities, 7.2 geometry of linear programming, 7.3 linear programming problem. Before we proceed, let me show you the flowchart or conceptual framework for our topics. Linear programming is a mathematical modeling technique in which a linear function is maximized or minimized when subjected to various constraints. This technique has been useful for guiding quantitative decision in business planning, in industrial engineering, and to a lesser extent in the social and physical sciences. Linear inequalities with the same solution are called equivalent inequality. There are rules for both equality and inequality. All the rules mentioned below are also true for inequalities involving lesser than or equal to and greater than or equal to. The 4 types of properties that are done on linear inequalities are addition, multiplication, dichotomy, and transitive. Addition property of inequality. For any numbers a, b, and c, if a is less than b, then a plus c is less than b plus c. And if a is greater than b, then a plus c is greater than b plus c. Examples, we have 1 is less than 2, we add 3 both sides of inequality. We have 4 is less than 5. And also we have 2 is greater than 1, we add 3 both sides of inequality. 5 is greater than 4. Adding same numbers to both sides does not change the inequality. And now we proceed to multiplication property of inequality. For all real numbers are a, b, and c, then all the following are true. Examples, we let a is equal to 2, then b is equal to 4, then c is equal to 3. 2 is less than 4. We use c to multiply the 2 is less than 4. We have 2 times 3 less than 4 times 3. The answer is 6 is less than 12. The inequality symbol does not change. The conclusion we say, if c is greater than 0, a is less than b. Then if ac is less than bc.
So, what is trichotomy property? The trichotomy property means that when you are comparing 2 numbers, one of the following must be true. The first number is bigger than the second number. The first number is smaller than the second number, or the 2 numbers are equal. For example, Todd has 4 apples and George has 10 apples. Which statement is true? Todd has more apple than George. Todd has the same amount of apples as George. Todd has fewer apples than George. So the answer is Todd has fewer apples than George. So what is meant by transitive property? The transitive property states that if 2 quantities are equal to the third quantity, then we can say that all the quantities are equal to each other. A property is called transitive property if x, y, and z are the 3 quantities, and if x is related to y by some rule and y is related to z by the same rule, then we can say x is related to z by the same rule. For example, find the value of x where x is equal to y and y is equal to 5. So our given is x is equal to y and y is equal to 5. By using the transitive property of equality, if a is equal to b, then b is equal to c, then a is equal to c, we can find the value of x. If x is equal to y and y is equal to 5, then x is equal to 5. Hence, the value of x is 5.
Geometric linear programming. Linear programming is a part of the much larger optimization discipline known as convex optimization. A linear equation creates a geometric entity called a hyperplane. The terms plane and hyperplane both refer to hyperplanes into 2-dimensional space. It is comparable to hyperplane in some ways. However, half space only cover one side of a hyperplane, An equanimity is half space, while an equation is hyperplane. Alternatively, a hyperplane is the edge of a comparable half space.
A three-dimensional shape with a flat polygonal faces, straight edges, and sharp corners or vertices is called a polyhedron. Common examples are cube, prisms, pyramids. However, cones and spheres are not polyhedrons, since they do not have a polygonal faces. There is a relationship between the number of faces, edges, and vertices in a polyhedron, which can be represented by the math formula known as Euler's formula. F plus V minus C is equals to 2, where F is equals to number of faces, V is equals to number of vertices, and E is equals to numbers of edges. If we know any two values among F, V, or E, we can find the third missing value using Euler's formula. So the question like how many edges does a polyhedron have or how many faces does a polyhedron have can be answered easily if the other two values are known. A convex set is a collection of points in which the line AB connecting any two points. AB in the set lies completely within the set. In geometry, a subset of Euclidean space, or more generally an affine space, over the reals is convex. If given any two points in the subset contains the whole line segment that joins them. Equivalently, a convex set or a convex region is a subset that intersects every line into a single line segment.
So my topic is linear programming problem. So what is it? The linear programming problems or LPP is a problem that is concerned with finding the optimal value of the given linear function. So we have two types of linear programming problem, which is fundamental theorem of linear programming. The second is solving of linear programming graphically. So what is fundamental theorem of linear programming? The maximum or minimum value of the objective function in a linear programming problem is achieved at one of the verticals of the feasible set. The example of fundamental theorem of linear programming. Solving of linear programming graphically is used for solving the problems by finding out the maximum or minimum point of the intersection between the objective function line and the feasible region on a graph. Example guys, z is equal to 5x plus 4y, 4x plus y greater than 40, 2x plus 3y greater than 90, x and y greater than 0. So we have the solution, the given graph, and the final answer.
Solving the linear programming problem uses simplex method. So there are 6 steps to follow using simplex method. Step 1. Insert slack variables. Insert the slack variable into each of the structural traits. Step 2. Rewrite the objective function. Rewrite the objective function to match the format of the slack equations and add the corresponding equation to the bottom of the slack equations. Step 3. Write the initial simplex tableau. The augmented matrix is called initial simplex tableau. Each number in the bottom row to the left to the vertical bar is called an indicator. Step 4. Find the pivot element. The most negative indicator in the last row of the tableau determines the pivot column. We apply the smallest quotient rule for the column. The pivot element is the most negative indicator in the third row. Step 5. Perform the pivot operation. The pivot element is equal to 3 corresponding to the lowest ratio 10. When you divide the constant column with the values in the pivot column, turn the pivot element into 1 and other values in the pivot column into 0 by applying a possible operation to obtain it. Step 6. If there are still negative values in the third row, if a negative indicator is still present, repeat step 4 and 5. If no negative indicators are present, the maximum of the objective function has been reached. So, if all the row has no negative values anymore, then we can say that the process is all done.